Tonight is the night. In just a few short hours, the strange emerald glowing traveler from beyond our solar system, known as 3I Atlas, will sweep past Mars. For months it has haunted astronomers, pulsing with an energy that no comet should possess. And now, the encounter has finally arrived. What unfolds in this brief window may not only change how we talk about interstellar visitors, it may shift the way we think about our place in the cosmos. This is not a rehearsal or a distant forecast. It is a moment that will be recorded in real time, with data that could confirm the suspicions whispered in observatories across the world, or else bury them again under the safer story of rocks and ice. Its arrival has already unsettled the careful routines of planetary science. Teams have worked through the night, shifting satellites into position, preparing every lens and receiver, knowing that the world will be blind once the comet slips behind the sun from Earth's point of view. In the next few hours, Mars and its fleet of orbiters will stand as our only unblinking witnesses. And so, while most of the planet settles into sleep, a handful of machines on a red desert world wait to capture whatever this visitor chooses to reveal. From the very beginning, 3I Atlas refused to follow the script of an ordinary comet. Most comets are discovered quietly, their faint light traced and catalogued, their behavior more or less predictable as they respond to the steady heat of the sun. But this object startled astronomers with sudden jumps in brightness far beyond what solar warming could explain. Instead of fading into routine, it seemed to breathe in irregular pulses, like something responding to a hidden signal. Its emerald halo made the mystery deeper still, a shade that stubbornly resisted every comparison with common comet chemistry. When spectrographs caught its first emissions, the readings were not what scientists expected. Instead of water ice driving its glow, the spectrum was dominated by carbon dioxide. At times, it showed traces of metals that had no business appearing in such concentrations. And even the dust around it was strange, with large, slow-moving grains that seemed to drift as if released in deliberate bursts rather than chaotic sprays. The pattern unsettled researchers who pride themselves on finding natural explanations. They could offer theories about buried pockets of volatile gas or unusual crystalline structures, but the pieces never lined up neatly. For some, the puzzle was so persistent that words normally avoided in professional circles began to surface in quiet conversations. Words like engineered or reconnaissance. That is the tension hanging over tonight's flyby. As the comet approaches Mars, every anomaly that has been logged now waits for confirmation. If the strange pulses, the chemical oddities, and the geometric precision of its path are real, then the next few days will decide whether they can still be forced into the safe model of an exotic comet, or whether scientists will have to widen their imagination. Astronomers have narrowed the puzzle to 3 specific features that keep them awake at night. The first is the geometry of the path itself. Unlike most interstellar visitors that slice through our solar system at odd angles, 3I Atlas hugs the plane of the planets almost perfectly, moving through a corridor where every world circles the sun. It is a trajectory that feels less like a random throw from the galaxy and more like a chosen lane. The second is its pulsing brightness. Instead of a smooth curve of light that rises with heat and falls with distance, the glow of 3I Atlas has surged and dimmed in a rhythm that seems intentional. Alongside those changes, minute shifts in its motion have been recorded by independent observatories, tiny accelerations that appear too regular to be accidents. The third is its composition. The high ratio of carbon dioxide to water is odd enough, but there have also been occasional spikes of unexpected metals that refuse to fit the template of any known comet. Each of these anomalies could be explained away if considered alone. A rare trajectory, a volatile-rich core, or an unusual crystal structure could be stretched to cover the data. But taken together, they form a pattern that is difficult to ignore. And now, as the comet sweeps past Mars, scientists are looking for decisive signals. If it fragments, the size and number of pieces will tell us whether its body is fragile or volatile. If its course changes more than predicted, the reason could be asymmetric gas release, or something stranger. If its spectrum reveals lines that do not belong to simple ices, then the case will no longer be easy to dismiss. Tonight, the tension is not just about science, it is about whether the explanations we have trusted will hold under pressure, or whether this emerald visitor will force us to accept that our solar system has been touched by something that does not fit the rules we know. That is why the events of tonight matter so much. As 3i Atlas races past Mars, Earth itself will lose direct sight for several days. The sun will block our line of vision, leaving us dependent on the handful of robotic eyes orbiting the red planet. Mars Express, MAVEN, and the Trace Gas Orbiter have been assigned the task of watching constantly, while surface rovers, if weather and bandwidth allow, will be listening for sudden shifts in dust, light, or charged particles. For this short window, they are humanity's only witnesses, a fragile chain of instruments standing between speculation and discovery. The stakes are higher than usual because Mars is not just another checkpoint along the comet's path. Its thin atmosphere and patchy magnetic fields make it a natural laboratory. If fragments graze the upper air, they could spark temporary auroras, or alter the ionosphere in ways the orbiters can record. A shower of fine particles might even settle, leaving a chemical trace on the Martian surface that future missions would have to untangle from native soil. And all of it will arrive in delayed bursts of telemetry, slowed by relays, interference, and the bottleneck of limited bandwidth. Every packet of data will matter, each number carrying the possibility of rewriting the narrative. That is why teams have been rehearsing data routes for weeks, setting up contingency systems so that nothing is missed. Tonight, those plans are finally tested. For the public, it may seem like an ordinary night sky, but for the people guiding these machines, this is the moment where the quiet hum of servers and the thin streams of numbers hold answers that may change our understanding of interstellar visitors forever. In the hours ahead, scientists have outlined 3 possible outcomes, each carrying its own weight of consequence. The most conservative scenario is that 3i Atlas behaves like a comet with unusual chemistry. It could flare brightly, shed a few fragments, and then continue its journey back into the darkness between stars. In that case, the discovery would still be extraordinary, offering fresh insight into cometary physics and interstellar chemistry, but it would remain within the realm of the natural. The second scenario is more troubling. If the nucleus of 3i Atlas is fragile, the stress of sunlight and gravitational pull could tear it apart. Large fragments could scatter into a debris field that drifts through Mars's orbital neighborhood. That would not threaten Earth, but it could raise the risk of micrometeoroid impacts against orbiters circling the planet. Even a pebble traveling at tens of thousands of miles per hour is enough to damage sensitive instruments. Engineers have accounted for this, but the tension of watching millions of dollars worth of hardware face a storm of unknown particles is very real. And then there is the third, most unnerving possibility. If the object shows behavior inconsistent with natural forces, synchronized pulses of brightness tied to measured accelerations, emissions in energy bands unexplained by simple sublimation, or coherent structures that appear in the debris, then the conversation must change. In that case, the word engineered would no longer be whispered. It would move on to checklists and reports, not because anyone wants it to be true, but because science follows evidence. Even when the evidence points toward possibilities we are not ready to accept. Tonight, these scenarios hang in the balance. The difference between a comet, a debris cloud, or something stranger will be revealed not in dramatic fireworks visible to the naked eye, but in streams of data captured far away on a quiet red planet. If fragments or dust from 3i Atlas do settle into Mars's skies, the consequences will reach beyond tonight's suspense. One concern is contamination. For decades, scientists have prepared to search the Martian soil and air for biosignatures, the faint traces of life that might once have existed there. If interstellar material rich in complex organics drifts into that environment, it will complicate every future mission. Was a molecule found on Mars truly Martian, or was it carried from a passing visitor born in some other corner of the galaxy? To answer that question, researchers will need precise documentation, time-stamped samples, and redundant readings from orbit and surface alike. But the question is not only technical, it is also moral. Who owns such data? Should it be treated as a global heritage, released openly to the world, or as a national asset, controlled tightly by the agencies who collected it? Behind the closed doors of mission control, quiet debates have already broken out. Some argue that transparency is the essence of science, that discoveries must be shared freely if they are to mean anything at all. Others argue that the first possession of such knowledge could carry strategic weight, that international politics cannot be ignored even in the face of cosmic mystery. What is clear is that the outcome will not just shape research papers, it will influence policy, exploration strategies, and even the philosophy of how humanity approaches the unknown. If the Emerald Comet leaves its fingerprint on Mars, then for years to come, every mission that lands or drills there will be working in its shadow. The line between Martian and interstellar chemistry may blur, and with it, the confidence that we can easily tell one world's story from another's. Behind all the headlines and speculation are the people who keep watch when most of the world is asleep. Inside mission control centers, engineers trade their days for long nights, their eyes fixed on shifting data streams, their hands steady over consoles as they wait for signals that may confirm or overturn their models. Weeks of preparation have narrowed to these tense hours, where a sudden spike or a brief blackout could send entire teams racing to verify what they have seen. For them, the emerald glow of 3i Atlas is not just a curiosity. It is a test of every instrument they have built and every calculation they have trusted. Beyond the agencies, an army of amateurs stands ready. In backyards from Arizona to Chile, small telescopes are pointed skyward, cameras set to capture each flicker of light. Citizen scientists share scripts that will automatically upload frames to shared networks, ensuring that if something extraordinary happens, no single point of failure can erase it. In forums and chat groups, volunteers coordinate observations, triangulating brightness changes, checking each other's results, and feeding the information upward to professionals who may use it to confirm or refine official data. It is a partnership that speaks to the restless curiosity of human beings, a reminder that discovery is not confined to billion-dollar spacecraft, but often begins with someone staring into the night sky from their own backyard. This ecosystem of vigilance, from the largest observatory to the smallest personal telescope, is what gives tonight its texture. The Emerald Comet is not only a challenge to science, but a mirror held up to us, showing how much effort we are willing to spend to catch even a hint of truth as it races past. For those awake to witness it, the moment is not abstract. It is alive with tension, anticipation, and the quiet understanding that the answers we receive may change the questions we ask tomorrow. By the time the sun rises and the first packets of data have made their long journey back to Earth, the world may be facing a very different picture of the cosmos. Perhaps the reports will describe nothing more than a volatile, rich comet that happened to burn brighter and stranger than most, its mysteries filed away under new categories in planetary science. That outcome would still be remarkable, a reminder that even familiar objects like comets can carry secrets waiting to be uncovered. But there is also the possibility that tonight will not end with tidy explanations. If the debris field proves larger than expected, if orbiters detect emissions that resist classification, or if the rhythm of those pulsing flares continues with precision too sharp to ignore, then the conversation will move beyond astronomy. It will step into philosophy, politics, even theology, as people struggle to understand what it means to encounter an object that does not behave like a random traveler. Questions that once belonged to science fiction could arrive at the desks of mission planners, senators, and philosophers. Were we just brushed by an engineered probe? If so, what was its purpose and who sent it across the gulf of space? Even without such dramatic revelations, the story of 3i Atlas already reminds us that the universe still holds surprises we cannot predict. We often assume that with enough telescopes and enough equations, the cosmos will bow to our understanding. But every so often, something green and glowing slips into the frame to remind us that our knowledge is temporary, and our place is not at the center, but on the edge, waiting to learn. Tonight, the choice is not between wonder and caution. It is to carry both at once, to look upward not only for answers, but for better questions. To remember that even a single flyby, a single emerald spark in the night sky, can stretch the horizon of what we think is possible. Whatever tomorrow's headlines bring, the simple fact remains. The universe has spoken, and it still has mysteries to share. For those who step outside tonight and look up, the sky may appear calm, a silent canvas filled with stars. The emerald visitor is not visible everywhere, and even where it can be seen, it may look like nothing more than a faint, unusual shimmer near Mars. Yet behind that faint light lies a story of months of vigilance, years of preparation, and centuries of curiosity. Every culture that has looked into the night sky has wondered about travelers from beyond, and now, in our own time, one of those travelers is here. It carries no banners, no messages, only questions wrapped in dust and ice. Yet those questions strike at the heart of what it means to be human. What 3i Atlas ultimately teaches us may not be decided tonight. Data will take days to process, weeks to analyze, and years to argue over. But the encounter itself marks a turning point. We are no longer simply imagining interstellar visitors. We are studying one in detail, confronting mysteries not from the safety of fiction, but from the hard edge of observation. If it fades and breaks apart, we gain a clearer picture of how other systems forge their comets. If it refuses to play by natural rules, then the debate will grow louder, and the definition of discovery will change with it. Either way, the emerald glow of 3i Atlas leaves us with something precious, the reminder that the universe is not finished surprising us. We live on a small planet, orbiting an ordinary star, and yet the cosmos still chooses to send us riddles that challenge our certainty. Tonight, as Mars becomes our eyes and ears, as orbiters and rovers record what we cannot, we stand at the edge of knowing, suspended between the familiar and the unknown. And perhaps that is exactly where science belongs, not in the comfort of final answers, but in the endless pursuit of better questions. So, as the world drifts into morning, one thing is certain. When the first streams of data arrive from Mars, we will not be reading the same universe we thought we knew yesterday. The numbers may describe a fragile comet tearing apart in the sunlight, or they may reveal a chemical cocktail unlike anything measured before. They may even hint at patterns too deliberate to dismiss. Each possibility will write a new line in the story of how our solar system interacts with the galaxy beyond. For scientists, the discipline is clear. Extraordinary claims require extraordinary evidence. Every instrument must be checked, every calibration verified, every result challenged by independent teams. The strength of science lies not in rushing to the wildest explanation, but in the process of ruling out error until only the truth remains. Yet even as that process unfolds with care, the sense of wonder cannot be denied. People around the world are following amateur channels, refreshing official feeds, and looking up at the sky with the quiet hope that they are witnessing history in the making. Whether 3i Atlas fades quietly back into the dark or forces us to reconsider the limits of natural explanation, the outcome will be a victory for curiosity. To chase the unknown, to aim cameras at a green stranger millions of miles away, to ask questions that may have no easy answer. This is the essence of exploration. The comet is small compared to planets and stars, but the implications of its visit are enormous. Tonight, it is not just a traveler from another system. It is a reminder that the cosmos is alive with surprises, and that our search for meaning among the stars is only beginning. And so we reach the end of tonight's journey. 3i Atlas has swept past Mars, leaving us with more questions than answers, and that is exactly why we watch the skies. The story does not finish here. The data is only beginning to arrive, and the debates will unfold for weeks, months, even years. What matters now is that we stay curious, because curiosity is the one tool that has always carried humanity forward. If you've stayed with me through this story, thank you for sharing your time under the stars. If you want to keep following the unfolding mystery of 3i Atlas and the many other wonders our universe holds, make sure you subscribe to the channel. Hit the like button if tonight's exploration kept you thinking, and share this video with a friend who still looks up at the night sky with wonder. Above all, remember this: the universe is vast, alive, and filled with surprises. We are only beginning to understand it, and together we will keep chasing its questions, one strange visitor at a time.